Hello and welcome. This is a presentation on the business value of health IT. More specifically, we'll be looking at the VistA system as it relates to the Department of Veterans Affairs health delivery system. First, let's take a look at the importance of evaluating IT investment. We should note that one cannot blindly believe that IT investment in and of itself reduces costs and increases revenue, but too often people use speculative methods to evaluate IT investment, often ignoring the negatives associated with it. An example of this might be a physician who logs his scripts and maybe patient orders in written form before logging the same orders into an IT system. All of this is accomplishing is doing double the work, and the IT system really isn't necessary because it's still all being written out by hand. Investment in IT should result in an improvement in productivity, not a doubling of productivity. It is possible, though, for increased revenues to lead to investment in IT, which says nothing about the productivity created by IT use. Let's take a little look at the VistA system as used in the Veterans Affairs system. VistA is a nationally recognized electronic health record. It's widely used by the VA healthcare system. The VA is the largest direct health delivery system in America. As of 2004, the VA had logged over just under 5 million patient records into their VistA system. And it's revolutionary because patients can go to any VA location and have records access, as opposed to how we used to do it, that is, or how we still do it in most hospitals. As you go to the hospital, they keep a paper record or even an electronic record that's non-transferable to other locations. Methods of analysis that we'll be examining, we'll be looking at two. First off is the popular approach, not the one we'll be using, but the popular approach. It identifies the business processes affected by information technology. It calculates the yearly net costs and savings of these business processes. It also calculates the value of savings and investments in present value terms of those business processes. And then it calculates the ratio of savings to the investment. The problem here is that this model encourages speculation because it asks managers to evaluate costs and savings of the IT they use, and notoriously costs are underreported and savings tend to be overreported, so it really is a flawed system. Okay, next we will be examining our method of analysis, which requires us first to gather objective data. The objective data we'll be gathering is the investment in IT technologies, usage of the IT, and revenues gained overall. Next, we have to verify that there are associations between our three data points, and as you can see, all three can have certain associations. Then we have to verify causality, which actually involves a few calculations you'll see in a second. These calculations will either show us that revenue led to more IT use, or they will show us that investment in IT led to revenue. This is what we are actually looking for, as if this is the case, we'll actually be able to calculate a return on investment, because there actually will be a return on investment. Next, we see the first of our three findings graphs. This is showing the relationship between the IT budget, or investment in IT, and cost per patient index, or the actual revenue from this. And as you can see by the R value, which is 0.89, there actually is a significant correlation here. R value of 1 would be a complete correlation. So it seems between IT investment and revenue there is a bit of a correlation. Next, we'll be looking at the relationship between the size of the VistA database and the cost per patient index, or the revenue. The size of the database shows usage, and the cost per patient index shows revenue again. The R value here is 0.57, which barely shows a correlation at all, really, if you look at the graph. So there isn't that much of a correlated finding between usage and revenue. Our last graph shows the relationship between the IT budget, or IT spending, and the size of the VistA database or usage of the database. Here again, we have an R value of 0.76, which is pretty good, much better than our previous graph. So it does show at least some correlation between spending on IT and usage of the system. Lastly, we actually make our calculations, and there are two possible threads that we can calculate that make sense in a cause, catalyst, end result type of relationship. The first is IT spending, it would be the cause. Then the catalyst of that would be usage of the VistA database or usage of the IT system, and the end result there would be a revenue. So basically that is a cause of investment in IT, end result revenue. We see a calculated value of negative 0.46. Our desire is for a calculated value of 0. That would show a correlation. So negative 0.46 is a good distance away from 0. Our second line shows revenue as the cause, shown by the cost per patient index. The catalyst is IT spending, and our end result is usage of the IT. Here we've got a cause of being outside revenue and end result of usage of IT. Our calculated value here is 0.12, which is significantly better than negative 0.46. So it seems to appear that the IT spending wasn't actually what caused the revenue, but rather revenue led to increased usage in IT. So we can't actually calculate a return on investment for this. Lastly, let's take a look at my references. I used, for a lot of the calculative stuff, a paper entitled The Business Value of IT by Dr. Alemi. And for a lot of the VistA related information, I took it from the Department of Veterans Affairs website, and a specific document called Medical Programs and Information Technology Programs from the fiscal year 2009.